So, hello everyone, and let's proceed ahead with the activation function. What we have studied in the previous class is activation function are the mapping functions, and various important tasks related to the data transformation is done by the activation function. As we have seen, the working of different activation function in the previous class, that data when received by the activation function, and the data is usually a value possessed in it that is very high. That is one of the possibility. And when the activation function is applied over that data, that value or the values are converted in certain range. We did started with hyperbolic tangent activation function, and in hyperbolic tangent activation function we learn that values are converted between -1 to +1. Then sigmoid activation function. Here the values are converted between 0 to 1. Then softmax activation function, also a member of sigmoid. But in case of softmax activation function, you are getting the results in form of probability, but not in a form of logit. That means sigmoid is a logit. However, softmax is not a logit. It give you probability. Then we have studied ReLU activation function, that is rectified linear unit. And if the input is negative, the output is 0. And if the input is positive, the output is 1. That's what the ReLU say. All of these activation functions are non-linear in nature. The reason is we have to capture non-linear relationship in the data. That was the reason. Okay. Because data is complex, and the goal of machine learning or deep learning is to understand pattern in the data, that complex pattern in the data. So by filtering the values, by using non-linear activation function, we try to understand pattern in the data, and then whatever be the calculations we are doing, we do ahead in our neural network. Okay, so this was kind of an architecture which we were using in case of neural network, that is artificial neural network. Okay, and we are available with the neurons on these layers, artificial neurons. And after giving input, okay, these neuron forward the result, which is wx plus b, to the activation function which has been used in the intermediate. So here I will be using an activation function. Here also I will be using an activation function. So this activation function is associated to this layer, and this activation function is associated to this layer. So from this layer I'm getting wx plus b. Okay. For example, let us consider. And I need to give this value to an activation function, and since it is in the intermediate layer, so the general activation function which is used in the intermediate layer is ReLU, rectified linear unit. Okay, and if you're doing the classification problem, for example binary classification, so we are having only one neuron at the output layer, and here we can put sigmoid activation function. Okay, and sigmoid is given as 1 upon 1 plus e की power minus x. This is sigmoid. If you're doing multi classification, in that you will be having multiple neurons here as per the number of classes. And the formula for softmax is e की power x upon summation of x. That's what we have seen in the previous class. Then we are having other activation functions like leaky relu, exponential linear unit, and swish. There might be others also. Okay, but these are some common activation functions which are used in a neural network. Okay, so let me share my entire screen again, and we should have a review on these activation functions. Okay, to mark some important points about the working of them. Okay, so here are my notes for activation function. They do play a crucial role in neural network. Okay, and they do produce non-linearity in the data. According to the chart, as I told, for binary classification, sigmoid. For multi-classification, softmax. For multi-label classification, multi-label bole to object detection. I hope you have seen in the computer vision. I also do share many of the projects on my LinkedIn related to the computer vision. Okay, वहां पर multi-label classification होता है. That means detecting various objects in a image or in a video. There also we are using sigmoid activation function. तो ये क्लासिफिकेशन का हो गया. फॉर क्लासिफिकेशन वी हैव टू यूज डिफरेंट ऑप्शंस, लेकिन रिग्रेशन के लिए वी आर हैविंग ओनली लीनियर एक्टिवेशन फंक्शन. और लीनियर क्या होता है? y इक्वल टू एक्स, दैट्स इट. या एम एक्स, जो भी कहना चाहो कह सकते हैं. y इक्वल टू एम एक्स प्लस सी लगाना लगा दो, कोई इशू नहीं, ये लीनियर हो गया. ठीक है. व्हेन वी आर डूइंग अ लीनियर या रिग्रेशन प्रॉब्लम, तो देयर वी आर यूजिंग दिस एक्टिवेशन फंक्शन. ठीक है. एंड जो एक्टिवेशन फंक्शंस है, दे वर्क एज अ गेट कीपर. दे आर रिस्पॉन्सिबल टू टर्न और ऑफ अ न्यूरॉन. Okay, so a neuron will only supply the output to the next layer neuron when the activation function permit to do so. If they will not, then nothing. Okay, so they are the building part of a neural network which plays a vital role, as we have seen. Without activation function also you can use the neural network, but the point is we are not going to get a proper or valid result. Without activation function also you can make a neural network, but still that means all the flow of energy will be just like unusual. Okay, so ultimately this activation functions are considered as a building block. Okay, and there are many reasons, as I told already: non-linearity and handling complex data, complex relationship. Okay, and also to convert the data into certain limit or a range. So there are many reasons for using activation function. Okay, these are the activation functions which are non-linear in nature: sigmoid, relu, 10h, elu. These are the non-linear activation functions. We are having linear activation function also. We are having binary function also. Okay. In general, we deal with these and this to some extent, but mostly used activation functions are these activation functions. Okay. Sigmoid, I already told yesterday, this is the formula: 1 upon 1 plus e की power minus x. This is the formula for sigmoid activation function, value between 0 to 1. Okay, and here is the graph for sigmoid. I explained yesterday only. Just like S. between 0 to 1, and you can see that value of x, you can put anything. This is x and this is y. You can put anything as an input. However, you will only get a value between 0 to 1. कुछ भी कर दो आप वहां पर, you can put anything. Okay, but the result you will only get between 0 to 1. Okay, यहाँ x में नेगेटिव पॉजिटिव जो भी वैल्यूज हैं वो सब पुट करा. ओके, एंड देन फिर नेक्स्ट क्या है आपका डेरिवेटिव. ओके, इफ यू डिफरेंशिएट द सिग्मॉइड फंक्शन, ओके, यू विल गेट सच काइंड ऑफ प्लॉट फॉर द डेरिवेशन. मतलब डेरिवेटिव करने पर. ओके, क्योंकि डेरिवेटिव होगा, किया जाएगा. Yesterday only I gave you an example where the points were mentioned related to convergence. At the end of the lecture, I was discussing related to what a convergence means, what an optimization means, what is error means here. So we have to differentiate. We will be solving a complete problem on a neural network, a numerical. There you will understand much more better. Okay. Then we also seen 10h activation function, -1 to +1. Okay, value, fine. And and in this 10h activation function here, the mean, when the input is close to 0, the output is also close to 0. That is the importance of 10h. When, ये बहुत ही इंपॉर्टेंट लाइन है, because 10h activation function also consider negative values and a positive value range. Okay, so 10h activation is similar to sigmoid, but it is centered around 0. That is very much important. Sigmoid is not centered about 0. Sigmoid gives a value between 0 and 1. लेकिन 10h 0 centered है, क्योंकि -1 to +1 की रेंज की वैल्यूज इट्स गिविंग. सो एट द सेंटर 0 है. तो जब इनपुट भी यदि 0 के क्लोज होगा, देन आउटपुट विल ऑल्सो बी क्लोजर टू द 0. दैट्स व्हाट द 10h परफॉर्म्स. Okay, it can deal with both negative and the positive values because it can help the network learn better. That is the reason it can make a network to learn better. Okay, fine. And ये रहा 10h का graph. Okay, this is 10h graph. Okay, between -1 to +1. Fine. X values can be anything, but जो values होगा वो -1 to +1 की रेंज में होगा, 0 centered होगा. If you take the differentiation, so it will get the values like this. Okay, according to the plot, what we are seeing here. Okay, yes, Anil sir, ask the question.
Sir, that tangent derivative weight is required, sir.
Yeah, yes.
Sir, tangent derivative weight is required, sir.
10h derivative. It is required, sir, because when we are doing the optimization, na, sir, there we have to perform this task, sir. Okay, during the optimization we will do. All right, we have to adjust the weights and all these things, na. So there, okay, in the optimization for calculation of the weights, so there we will be applying these things. Okay, because what we know about the weight update, it is given as like this: w dash is equal to w minus alpha del l by del w. This is the optimization equation. Okay, so here the derivative of loss has been taken. Okay, and and how we have gone through this process, we have gone through this process by this wx plus b, and then y, this output y is given to the activation function, then only you are getting the final y. Okay, so this y dash you are achieving after going through the activation function. Okay, sir, and things will be much more clear when I will be showing you the numerical. Okay, sir, fine. So right now they are showing the plot of activation function, and they are also telling that how the derivative looks like. Now there are few things which are very much important related to the 10h. 10h activation function is preferred for hidden layers. Remember, We never use 10h activation function, okay, on the output layer. It is preferred for the hidden layers. Okay, so we can apply it, and the benefit is zero centered. Okay, this zero centered output has a learning process much more better. Okay, and obviously because of this range values, centering the data is around the zero. Okay, we'll always get a value between -1 to +1, so it will be zero centered. It will be applied over hidden layers, that means intermediate layers. The sigmoid activation function is commonly used at the output layer for binary classification that I already taught. Okay, its value is between 0 and 1, and it is ideal for representing the probabilities ahead, okay, which we have seen in the softmax. Okay, and the benefit for using sigmoid at output layer is because of the class probabilities. Okay, that means data belongs to which class? Class A, class B, whatever. Okay, we have also studied few more things related to the sigmoid, that it will give you certain value like this, zero point 0.7, zero point 0.4, something like this. It doesn't mean that the sum of the values will be equal to 1. In sigmoid, it's not mandatory that the sum is equal to 1. Whatever be the output you are getting, okay, the highest value you are going to consider as an answer. Okay, and then there are certain issues related to both of them. Sigmoid and tanh functions can have very small gradients when the input values are very large or very small. Small gradients can slow the learning process during the gradient descent. That is the optimization technique. That is what I did explain previously. Okay, so if you are able to understand what is happening here, is you have already seen the architecture, you have already seen the layers, you know that neurons are present on the layers, you know what is the maths happening, you know after getting this result where to put the value of y. Okay, finally, after all these things, you will get a result. And yesterday only I told that once you get a result by this feed forward process, this is called as feed forward, आगे की तरफ. Okay, so once you get a result, you match it with the actual, and after matching with the actual, you calculate the error, predicted minus actual. You calculate the error. If the error is more, you have to reduce the error. For reduction of the error, you have to perform optimization. That means you have to differentiate error with respect to weight. Weight is a parameter which we require to adjust. Okay, here weight and the bias are the parameters. That is what we have to adjust. And the formula for adjustment is given as W dash is equal to W minus alpha del L by del W. This is a general formula. So you have to perform the differentiation, partial differentiation of loss with respect to weight. This is learning rate, which is also called as a step size. Okay, and logically, this process of optimization is understood in a form of a diagram that, for example, you are present at the top of the hill and you have to go down, 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 more down. You have to reach to a minimum value, minima. You are at the moment present here. Then you are identifying certain points to reach the minima. This is minima. At minima, the error will be least. Okay, so the process of partially differentiating error or loss with respect to weight and identifying new weight is optimization, and ultimately you are looking forward to go down. That is called as gradient descent. Going down is called as a descent, and you are calculating the gradient of loss with respect to weight. That is why it is called as gradient descent. Descent यानी नीचे की तरफ और gradient निकाल रहे हो, तभी gradient descent कहते हैं. And why down? Because there is high error at the top, and by finding the path below the hill, we are trying to update the weight that will be in a such a way now that the prediction and the actual will nearly become same. That is what we are doing. तो लर्निंग कहते किसको हैं? Whom we are calling learning? Adjustment of parameters is called as learning, whether it is machine, whether it is deep. ये पैरामीटर का एडजस्टमेंट करना, वेट और बायस की वैल्यू. ओके, द एडजस्टमेंट ऑफ वेट एंड द बायस वैल्यू, द आइडेंटिफाइंग द वेट एंड द बायस वैल्यू, दैट इज कॉल्ड एज अ लर्निंग. यही है और कुछ भी नहीं. ओके, so what they said here is both sigmoid and 10h, they are having very small gradients. Because of this reason the learning can be a bit slow. Slow बोले तो it will take time to reach minima. Okay, my model learns, that means my model updates the value of parameters according to this formula. However, they are saying that the gradients which are calculated if we are using the sigmoid and the tanh activation function, they are having less values. So the update in the weight will be less. Therefore, learning will be a bit slow, and reaching the minima will take a time. Okay, that is one of the issues which they have mentioned. Problem. So we have used ReLU, rectified linear activation function also. इसको भी use कर सकते हैं. And here it is. I already told. If the value is negative, answer is 0. And if the value is positive, answer is 1. That is ReLU activation function. Okay. So in ReLU activation function, here is the formula. Yeah. Okay. If the value of x is greater than 0, then the derivative is 1. If the value of x is less than 0, then the derivative is 0. There is a special case when z equal to 0. In that, the derivative is not well defined, but it is a rare of the rarest problem, because you can see the plot of ReLU is like this. यदि कोई भी नेगेटिव वैल्यू है, the answer will always be 0. And when the value becomes positive, the answer will be same as it is. लेकिन इस पर क्या होगा? If any of the value is already 0, then what will happen? तो उसने कहा ये रेयरेस्ट केस है. दिस इज अ रेयर केस. वैसे तो उसको जीरो ही मार्क कर रहा है. हियर द डेरिवेटिव विल बिकम डिफिकल्ट. जीरो पर डिफरेंशिएबिलिटी कैसे डिफाइन करो? ओके, दैट इज एन इशू. ओके, बट लेट इट बी. लीस्ट केस है, इट विल नॉट ऑकर. And ReLU activation function is one of the famous activation function, and we do use it in our artificial neural network and convolution neural network in the intermediate layer. Okay, so choosing activation function I already told. Binary के लिए sigmoid, hidden layers में ReLU. Okay, in hidden layers we do use ReLU. We can use 10h also. Okay, we can use 10h also, but ReLU is computationally efficient. Okay, ReLU is computationally efficient, and it avoids vanishing gradient problem. That means if you calculate the gradient Okay, if you calculate the gradient del L by del W, it should not tend to zero. यदि ये जीरो हो गया, if it becomes zero, so W dash is equal to W minus alpha del L by del W. यदि ये जीरो हो गया, so zero into alpha is zero, so W dash will equal to W. That means there is no update in the weight. Then weight is not updated, then we will say that there is no learning happening. Okay, so we don't want this thing to get zero. We want something to be calculated out of gradient. That is the only thing that we say as a learning part. Then only these parameters will be updated, else it will not. Okay, so relu is an activation function. We say that okay, I will. There is. I am very simple. I am computationally efficient, and I will try whatever possible from my side. I will not make the gradient calculation towards zero. Okay. However, we have seen that if there are negative values, then ReLU will convert them into zero. So, in order to overcome that, leaky ReLU activation function came into the picture. And leaky ReLU is an extension of ReLU only that attempts to solve dying ReLU problem. Dying ReLU means again, uh, that means your gradient is getting towards the zero. That is called as dying ReLU. If in our data set there are many negative values, if we turn all of them to zero, तो इश्यू हो जाएगा, गड़बड़ हो जाएगी, सारे जीरो हो जाएंगे. तो उसको बचाने के लिए, in order to save, we are using leaky ReLU. That means the leaky ReLU set them to all positive values such as 0.1 times of the input, and this guarantees that even if the neuron receive negative information, still it will learn. यदि नेगेटिव भी आएगा तो जीरो नहीं होगा वो, still it will learn something. Okay, that's what it will do. ये leaky ReLU है. This is leaky ReLU. Yesterday only I made a diagram that अब वो zero, ये flat नहीं होगा, zero नहीं करेगा, उसको नीचे कर दिया उसने. And then ये वाला तो portion will remain same, इसको कुछ नहीं हुआ. If any of the value is greater than zero, then it will remain the same. But वो जो negative वाला value है, उसको zero नहीं करता, उसको वो थोड़ा सा down कर देगा. Okay, ये leaky ReLU है, उसी को leak कहा उसने. ऑल राइट, तो ये रेलू है एंड ये लीकी रेलू है. दिस इज द फॉर्मूला फॉर लीकी रेलू. ए जेड कॉमा जेड, दिस इज लीकी रेलू फॉर्मूला. ए जेड कॉमा जेड, that means if a value is negative, if a value is negative, okay, if the value is going to be negative, then you have to take like this, maximum of az and z. It looks like this. Okay, let me write the formula. Alpha z, it's not a, that is alpha, and this thing, whatever be the maximum of these, it will take, where z is the input. Okay, where z is input, and is alpha is 0.01. It is taking any of the value. एक ये कांस्टेंट ले लिया उसने, स्मॉल कांस्टेंट है अल्फा का वैल्यू, दैट इज 0.01. So instead of being zero when z is negative, यदि z नेगेटिव हो गया तो उसको जीरो नहीं बनाना. डोंट मेक इट जीरो. लीकी रेलू अलाउस अ स्मॉल नॉन जीरो वैल्यू टू इट, दैट इज अल्फा z. ये कर देगा. ओके, तो भाई क्या होगा? फॉर एग्जाम्पल, लेट अस सपोज वैल्यू इज -0.5, तो रेलू उसको जीरो कर देता. लीकी रेलू विल नॉट मेक इट जीरो. वो क्या करेगा? देखो, उसको बोला गया है भाई योर वैल्यू इज -0.5 ना, तो अल्फा इंटू जेड, यानी अल्फा है 0.01 मल्टीप्लाई बाय 0.5, इसके साथ माइनस भी, एंड जेड इसके साथ है minus 0.5. Now tell, इनका मल्टीप्लीकेशन करो, how much it is? 0.01 into 0.5, how much it is? That is minus 0.0000, या ऐसा हो जाएगा 0.005, -0.005. तो एक तो ये वैल्यू, एंड अनदर इज दिस वैल्यू विच इज मैक्सिमम हियर, विच इज मैक्सिमम ऑब्वियसली ये वाला मैक्सिमम. सो -0.005 इज मैक्सिमम. ओके, दैट विल बी सिलेक्टेड इन लीगल. तो क्या होगा, ये मिलेगा आपको, ये नीचे डाउन. पॉजिटिव है तो कोई इशू ही नहीं है फिर तुम्हें. पॉजिटिव में तो आई एम गेटिंग द सेम एज लाइक वैल्यू, बट इन केस ऑफ नेगेटिव आई एम यूजिंग दिस टेक्निक, अल्फा जेड कॉमा जेड. पॉजिटिव में भी यही है भाई, लेकिन क्या है कि वो, फॉर एग्जाम्पल इफ यू गेट पॉजिटिव वैल्यू 5, फॉर एग्जाम्पल जेड इक्वल टू 5, तो व्हाट इट इज डूइंग, अल्फा जेड क्या हो जाएगा 5 इंटू 0.01, तो ये हो जाएगा 0.05, और जेड क्या होगा, वो होगा 5. इन दोनों में से मैक्स कौन सा है 5, तो वो रेलू की तरह ही हो गया. So this alpha z and z, they are playing major role when the value is negative. Only the concern is leaky ReLU doesn't want the values to get zero. At least it wants something to be present. Because if we make all the values zero, so again there will be issue during gradient calculation. तो leaky ReLU prefer कर दिया. You should be able to understand data. Whatever be the maths which I am telling you right now, that will only be understood by you if you know about the data, what is available with me. Because you have to apply all these functions or techniques over data only. And I always say in my classes that a person who understand data is only the person who is scientist. If you don't understand the data, nothing. Forget. If you understand the data, then only there is some possibility, else nothing. भूल जाओ फिर तो सब. Because you will not able to crack what kind of function I need to apply, and there are many things which you do over the data. So data understanding is important. Okay, तो ये रेलू का काम हुआ. Fine. And after, हाँ, where to use ReLU? Where to use ReLU and leaky ReLU? Again, intermediate layer. Okay, leaky ReLU can be used as an alternative to ReLU. That will work much more better when we are having dead neurons. By preventing dead neurons. That means they are not giving anything. Zero zero दे रहे हैं तो dead ही हो गए वो तो. Okay, so there we can use the ReLU. Okay, that means at the hidden layers. Okay, fine. Then advantages तो हैं इसके, and the advantages are that, okay, computational complexity very less. That is the advantage. Okay, the rest more things are written that you can study. All right, the main criteria I have told. Okay, exponential linear unit. So whatever be the activation function which you have studied so far, you should have a clear state of mind when, where to use what activation function, what they will give. Now these are some special activation functions which are least used, but they are getting famous right now. In some problem statements we are using them. That is exponential linear unit, ELU. So that is another activation function which is gaining prominence in recent years. Okay, like ReLU, the aim is to address the vanishing gradient problem. See, whenever you study na deep learning, they always put a concern: vanishing gradient descent problem. That means this del L by del W, इसी को बोल रहा है वो कि ये कहीं जीरो ना हो जाए. क्योंकि यदि ये जीरो हो गया तो फिर वो तुम्हारा पूरा खेल बिगड़ जाएगा. ये ठीक है, ये वाला पूरा खेल बिगड़ जाएगा और डब्ल्यू अपडेट नहीं होगा. The complete game will be over if this becomes, yeah, this tends to zero. In order to make a network learn, we want to keep them alive, active. इसका वैल्यू निकलना चाहिए कुछ ना कुछ. ठीक है, तो वैनिश ना हो जाए, ये प्रॉब्लम है. तो वट एवर विद द एक्टिवेशन फंक्शंस वी आर यूजिंग, एंड वी टोल्ड the task they perform. First, sir, non-linearity. Second, sir, to convert data into certain range. Third, very important, to not have vanishing gradient problem. Again, a very important point to be added in activation function. ये नहीं होने का. Okay. So we are trying and experimenting different activation functions. See, you as I told that data, you should have an understanding of data. अब भाई data बहुत बड़ा है. Data is big. It is difficult to understand everything about the data. Okay. So what you do? You make a neural network. You make an architecture, and you add layers. You keep the neurons. You use the activation function. Whatever the basics which you know, you apply. But still, if you are not getting correct results, then you have to do changes. Then you can use different activation function, and there are many other things to be changed. Okay, so right now they are introducing ELU. For example, if you're not getting the result by ReLU, if you're not getting the result by leaky ReLU, दोनों ही फेल हो गए, तो ELU ट्राई करो. Try ELU. If both fails, ReLU, leaky ReLU, then try ELU. ELU क्या करता है? ELU introduce a non-zero slope for negative inputs. ये कुछ ऐसा है. It's like this. Non-zero slope. ये होशियार हो गया, स्मार्ट. क्यों? क्योंकि रेलू में और लीकी रेलू में मैं यहां पर फंस रहा था. At a point, at a particular point, there was a junction where the inputs are zero. तो यहां पर डिफरेंशिएशन निकालना बड़ा टफ है. How to find differentiability at point x equal to zero? That is the question. यहां पर मामला सब गलत सलत हो रहा था. द मैटर इज डिस्टर्बिंग. तो उस भाई ने क्या करा, ईएलयू ने, उसने इसको एक्सपोनेंशियली बना दिया. ये लो, इट कन्वर्टेड द प्रॉब्लम इनटू एक्सपोनेंशियल. So here, instead of getting a point at x equal to zero, I'm getting a turn. Okay, ऐसा कुछ मुझे बनते हुए नजर आ रहा है. Okay, ELU introduce a non-zero slope. वहां पर जब आप gradient निकालोगे, if you calculate a gradient or if you differentiate, तो भाई जीरो नहीं आए, उसको नॉन जीरो में कन्वर्ट कर दिया उसने. ये स्मार्टनेस लगाई है. Okay, and what is the formula? Here is a formula for exponential linear unit. If x is greater than equal to zero, तो xc है, तो इतना पार्ट तो रेलू वाले ही है. दिस इज लाइक रेलू ओनली. लेकिन यदि x छोटा हो गया जीरो से, तो उसने इसको एक्सपोनेंशियल में कन्वर्ट कर दिया. e की पावर x माइनस वन, अल्फा इंटू e की पावर x माइनस वन. It converted the negative values into exponential format. The reason is, sir, if you will calculate the gradient, obviously you will calculate, करना ही होगा. तो भाई मैं फंसूंगा नहीं. आई विल नॉट गेट ट्रैप्ड एट दैट पर्टिकुलर पॉइंट. यहाँ पर वो ग्रेडियंट ही नहीं निकाल पाऊंगा एक्स इक्वल टू जीरो पर. यहाँ उसको एक्सपोनेंशियल में कन्वर्ट कर दिया उसने. एंड अगेन अल्फा इज अ हाइपर पैरामीटर, इट्स वैल्यू विल बी लेस, 0.01 ही ले लेंगे उसको. Okay, we'll take something like the value of alpha. Ultimately, this will be an exponential because you are seeing e की power x. Okay, fine. So if your problem is not solved with ReLU, if your problem is not solved with leaky ReLU, then you can try ELU, exponential linear unit. Okay, then हाँ, ELU have shown to improve both training and the test accuracy. ये improve कर देगा score. है ना, where you are facing difficulty with ReLU. Okay, so very important. Short max I already explained in the previous class also, and here it is. So formula मैंने एक बार शायद I think I did a mistake. The formula is e की power x summation of e की power x. ये formula है short max का. Okay, I wrote at the opening of the class like this: e की power x summation of x. No, it is e की power x summation of e की power x. ठीक है. So short max is again, as I explained, it's a part of sigmoid only, but it is used for multi classification. It will calculate the probability. Okay, for each and every class, and the sum of the probability is equal to 1. So when you are dealing with a multi classification, use softmax activation function, and softmax is used at the final layer, output layer पे लगाते हैं. ठीक है, वहीं लगेगा ये, बीच में मत लगा देना कहीं. Don't apply softmax in between, only at the output layer, and when you are having multi classification problem, then only. Okay, fine. So multi classification problem. All right. Then we are having one more activation function that is called a swish. Okay, swish is also gaining an attention now in deep learning. Again, to have an improved performance. And this is the formula: 1 upon 1 plus e की power minus beta x into x. This is swish. It is similar to ReLU. Okay. And again, if ReLU is facing a problem, swish activation function is applied. Why? Because again, you made the things exponential. Okay, now you are introducing a curve so that the differentiability can be achieved. Okay, so exponential maybe we are achieving the differentiability, or यहाँ पर भी we are achieving the differentiability. Okay, so if ReLU faces problem with certain values of the data, other activation functions can be used to overcome that. Swish is also one of them. Okay, it is also computed efficiently. It will give you smooth curve. It will prevent from dying ReLU problem. Okay, that means no output is coming, zero is coming, so you can use the swish activation function. All right, so these are certain activation functions. There could be many more, but these the list of these activation functions are good enough. All right, fine. Now, what are the advantages and disadvantages of different activation function? Let us go through them. Okay. So we have a recap of the activation functions. First one is sigmoid. So sigmoid binary classification, that is the advantage. Disadvantage can be vanishing gradient problem. Okay, vanishing gradient problem. Rarely used, only at the hidden layer it is used to perform binary classification. बीच में कहीं use नहीं होगा sigmoid. Only at the only at the output layer. Okay, 10H activation function, it is preferred over sigmoid, and it is used at hidden layer. Okay, तो आप चार्ट बना लो कौन कहाँ यूज कर रहे हैं, कैसे यूज कर रहे हैं. अभी I will show you the code also practical. Okay, so you can make a table. Okay, so here it is. Activation function sigmoid कहाँ पर यूज करना है, आउटपुट पे. 10H where to use, hidden layer, इंटरमीडिएट में यूज करना. ओके, क्या फायदे हैं क्या नुकसान है, व्हाट आर द एडवांटेज डिसएडवांटेज. अगेन, वैनिशिंग ग्रेडियंट प्रॉब्लम, इट कैन सफर विद वैनिशिंग ग्रेडियंट प्रॉब्लम फॉर वेरी लार्ज और स्मॉल इनपुट्स. ठीक है, तो सिग्मॉइड एंड 10H, दे आर हैविंग द सेम काइंड ऑफ डिफिकल्टी, वैनिशिंग ग्रेडियंट. रेलू, okay, it is the best choice. Okay, that is considered as a default but best than the 10H. Okay, use at a hidden layer, that will speed up the performance. However, it will try to avoid vanishing gradient problem, but there is an issue: neurons can die and stop learning, because if the output are zero, then फिर क्या सीखेगा, क्या जब सभी जीरो कर देगा भाई तो सीखेगा. So that is called as dead. There will be no learning because ReLU negative values are present in the data, the output is zero. And if the output is zero, nothing to learn. So that is an issue which is faced by the ReLU activation function. Rest is fine. Okay, rest is fine. That means it is better than the 10H. Okay, it is used at hidden layer. So ReLU, hidden layer. Okay, what is next? The next activation function is leaky ReLU. That is much more better than the ReLU, and it will try to solve a problem of dead neuron by giving some value that is alpha x to the negative values. इसको ये अल्फा पैरामीटर से मल्टीप्लाई करेगा, जीरो नहीं करेगा, जीरो नहीं होने देगा, एटलीस्ट इट विल हैव सम वैल्यू. So alpha x it will do. So try to solve a problem of dead neuron. Okay, then there are other activation functions, for example parametric ReLU. Okay, that means it learns the slope of the negative values during training. So parametric की जगह we are talking about ELU, exponential linear unit, ELU. Okay, that means during the points where the value of x is equal to 0, we're getting an exponential curve. So gradient can be calculated, and it will address the problem of vanishing gradient descent also, and it will address the problem of dead neuron also. यहाँ पर जीरो नहीं होगा है ना, here also not zero, because you can see ऐसा बन रहा है, it is like this. So there will be nothing zero. Okay, so when the values are negative, exponential, or when the values are positive, straight line. काम खत्म हुआ. Okay, fine. And then sort max. I told multi classification, probability conversion. Okay, then and where to use output layer. Then swish can lead to a better performance. Requires calculation on the sigmoid function. Okay, and they haven't told that where to use the swish, but I believe it will be used at the hidden layers, because swish is claiming that it is better than the ReLU. It is like ReLU, so ReLU is used at the hidden layer, we are using swish also at the hidden layer. And formula you have seen above, 1 upon 1 plus e की power alpha x multiply by x. This was certainly the formula, x into 1 upon 1 plus e की power alpha x. This is swish. Okay, fine. So we just try to make non-linear activation functions whatever possible from our side. All of them are non-linear. You are getting the curve. You are getting certain range of values in which they are defined. So they are reducing, they are filtering the large amount of value. They are trying to capture the non-linearity in the data. They are also trying to improve the learning of a model by trying to avoid vanishing gradient problem. They don't want a gradient to become zero. If it is possible that the neurons which we have seen in the ReLU case, that they are getting dead because of zero, then we can change the activation function. We can use leaky ReLU. Still, if we are having a problem, we can use exponential. Okay, exponential ELU, and then we can use if we are having swish. बट यहाँ तक बात आएगी नहीं. ओके, रेलू से काम करते हैं, लीकी रेलू का भी यूज करते हैं, कम ही है वो भी. ओके, बट नाउ दे आर गेटिंग फेमस. लेट्स सी हाउ द आर्किटेक्चर्स आर बिल्ड, then only we can check the performance. Okay, so I have made certain coding examples for you. Okay, I made some coding examples so that you can learn from this how to make an how to make a use of this activation functions. Okay, so with the help of a code, let us understand. All right, so here is my Jupyter notebook. import numpy as np. If you want to do some maths, if you want to perform linear algebra calculations, numpy is a library which is used, that is called as numerical python. If you know how to work using numpy, that is good. If you don't know, kindly go through it. First you have to install numpy, then you can use it, you can import. So I have imported this numpy library. Okay, and then I am defining sigmoid activation function, df sigmoid. I'm making a function in which I will give a value, and what it will return, it will return this thing, 1 upon 1 plus np dot exp minus z, यानी कि वो यही है, वो ये 1 upon 1 plus e की पावर माइनस एक्स, इट विल रिटर्न दिस थिंग, ये रिटर्न करेगा वो, which is actually a sigmoid formula. That's what it is returning. ठीक है, और आपको करना क्या है, वेयर टू अप्लाई दिस, वेयर टू अप्लाई, यू हैव टू अप्लाई दिस इन wx plus b. ओके, तो आपका बोला उसने कि z चाहिए उसे, z एज एन इनपुट, तो z का वैल्यू क्या होगा, wx plus b. So you calculate z and give it to here in the sigmoid activation function. यही करा है मैंने कोड में. I have defined sigmoid activation function. Then I have calculated, this is forward pass. So you are doing forward pass only ना. ये क्या था, ये forward pass ही तो था. You're doing forward pass. And in every forward pass you are calculating wx plus b. तो यही करा है मैंने. I am having x, w and b. That means I am having input, I am having weight, I am having bias. And what I did, I calculated the dot product of x and w and I added bias to it. And I gave whatever with the result I got into sigmoid. And then the result which I got, that is A. For example, A is the result which I got after giving this to the sigmoid. And I am returning A. So, for example, this is the value of x, 1 and 2. These are the weights, zero point 0.5 and minus zero point 0.5. Okay, so how this network is built? बहुत ही सिंपल नेटवर्क बनाया मैंने. फॉर एग्जाम्पल, यू आर हैविंग टू इनपुट्स. ओके, you are having two inputs, x1 and x2, and the weight associated with them are w1 and w2, and let us suppose b with the bias. Okay, so you are having 1 and 2 as an input. Okay, so this is 1, this is 2. What is the weight? 0.5 and minus zero point 0.5. Okay, just put it down. 0.5 and minus 0.5. These are the weights. Weight negative हो सकता है भाई, ये क्वेश्चन नहीं पूछा. Weight can be negative. Weight is controlling na how much input or how much this value I need to transfer ahead. So weight is in a controlling position. It can be negative also. Okay. So here the weight is zero point 0.5 and minus zero point 0.5. And then I'm taking the bias. Again, I'm adding some more stuff to it. Bias, that is zero point 0.1. Okay, so just make here as zero point 0.1. So what will be the calculation? What will be the calculation? x1 w1 यानी 1 into zero point 0.5 plus x x2 w2 यानी 2 into minus zero point 0.5 plus bias zero point 0.1. I hope this makes a sense. And it should be clear to each and every one of you because you are now at the day number 4 of my class. What will be the result? 1 into zero point 0.5 is zero point 0.5. 2 into zero point 0.5 is 2 5s are 10, so it will be 1 actually. 2 into zero point 0.5 is 1 and माइनस है वो वहां पे, तो -1, और ये है 0.1 प्लस 0.1. So 0.5 minus 1 is minus 0.5 plus 0.1 is minus 0.4. This is the answer. Okay, minus 0.4 is the answer. You got the value of z as minus 0.4. Now you have to give this value of z into sigmoid. है ना, सिग्मोइड में दिया है, देखो कोड में बोला ना कि सिग्मोइड में दे दो, वट एवर बी द वैल्यू ऑफ जेड यू आर गेटिंग, गिव इट टू द सिग्मोइड, तो दे दो -0.4. So what is sigmoid? 1 upon 1 plus e की power minus z. What is z? Z is minus 0.4. So it will be minus of 0.4. कितना आ जाएगा ये? 1 upon 1 plus e की power 0.4. अब कैलकुलेटर से निकाल लेना आप. जरूरत नहीं है. It did the computation. The answer is 0.4. एंड वी वेरी वेल नो कि भाई सिग्मोइड तो 0 से 1 के बीच में देगा, तो देख लो 0.4 0 से 1 के बीच में है. Okay, you are getting the result between 0 to 1. 0.4. और सर रेलू भी बता दो सर, हाउ द रेलू वर्क सर. ठीक है, ले लो रेलू, ले लो. ये रहा रेलू. रेलू में क्या डिफाइन कर, एनपी डॉट मैक्सिमम 0 और z. यदि नेगेटिव वैल्यू होगा तो 0, पॉजिटिव होगा तो सेम. हो गया रेलू. अगेन सेम फॉरवर्ड पास, है ना, वही डब्ल्यू एक्स प्लस बी, एंड वट एवर भी द वैल्यू आर गेटिंग ना, उसको रेलू में दे दो. तो क्या वैल्यू आया था आपका? व्हाट वाज द वैल्यू गॉट इन z? -0.4. तो अकॉर्डिंग टू रेलू व्हाट शुड बी द आंसर? बोलो, व्हाट शुड बी द आंसर अकॉर्डिंग टू रेलू? 0. Sir, because the answer was 0.4, the z was 0.4, which is negative. So ReLU says for negative the answer should be 0. यदि लीकी रेलू होता, इफ इट वॉज लीकी रेलू, तो -0.4 इंटू 0.01 करना पड़ता. ओके, तो ये करना पड़ता. And the answer would be, in that leaky ReLU case, will be 0.004. This would be the answer if you take leaky ReLU activation function. But अभी यहाँ पर ReLU लिया था, तो you got the answer as 0. अच्छा, tan h लेंगे तो क्या हो? If you take hyperbolic tan h, तो tan h ना ऑलरेडी numpy के अंदर अवेलेबल है. You do not have to make a formula here. e की पावर x plus e की पावर minus x upon e की पावर x minus e की पावर minus x. ना, 10h is already present in numpy, so you can directly access np.10h z. Okay, कर सकते हैं. हाँ, अगेन फॉरवर्ड पास wx plus b, whatever with the result you are getting ना, give it to the 10h hyperbolic 10, and the final answer is -0.3799. That's what you are getting. ये मिल रहा है. Okay, fine. So these are the three activation functions which I thought that I want you to know that how to apply. And this is the architecture. Here is the architecture of the code which we have built. That we are having one neuron, for example, you are having one neuron, and all these are the operations which you are performing. Okay, fine. Next, we can make complete artificial neural network. Here I was showing you very simple operations, whatever you have learned. We can make a complete architecture. And what is the way to make a complete architecture? That I will elaborate tomorrow again. Okay, right now I'm just giving you a hint. TensorFlow. TensorFlow is a framework of Google to perform deep learning. You have to install this TensorFlow. There are other frameworks also to perform deep learning operations. Currently, I'm using TensorFlow. Okay, it's a framework. That means it will provide support to different operations. For example, model development, addition of the layers, adding neuron in the layer, adding activation function. Everything will be supported by TensorFlow. From TensorFlow only, I am picking TensorFlow.keras.models import sequential. See, remember one thing. Whatever be the model or the architecture you are making, it is sequential in nature. Okay, that means you are going to add layer and layer and layer. This is sequential. In a sequence, you are adding the layers in a sequence. So you always have a sequential model. Here you are making a model, so it is a sequential model. Why? Because here you are adding the layers one by one. I I haven't seen anywhere that you do right model as parallel. Nah, you will never ever see this thing that model as parallel. From TensorFlow, Keras models import parallel. Nah, no. You'll always see sequential because I need to add layer, then layer, then layer. इट डजेंट मीन कि सर आर्किटेक्चर में आप पैरेललाइजेशन नहीं कर सकते. कर सकता हूं भाई, मैं आगे बताऊंगा. कर सकता हूं, बट सिक्वेंशियल मॉडल. Dense is a layer. So intermediate hidden layer is called as dense only. कई नाम है इसके, है ना. इनको dense बोलते हैं, hidden बोलते हैं, intermediate बोलते हैं. Whatever you want to say you can. However, यहाँ पर import dense के नाम से use. So this is the meaning of the libraries which I am importing to make a artificial neural network. Now, I request you everyone to go through each and every activation function. If you have any doubt, you can please come up with the doubts. Then you should be knowing about the libraries because I will be demonstrating this code. I need to explain you the architecture of artificial neural network. Okay, I will be using a data set also I will be using to show you how the training is going on. Okay, that means I want you to learn how to make a architecture for deep learning. Okay, then I will show you the plots related to the accuracy and the losses. This is what my plan is. So in tomorrow class, I will rediscuss these codes. Okay, and I want you to learn how to make the code, how to use this TensorFlow and other libraries.
Sure, sir. Sure.
Okay, so it is mandatory for everyone. So at least go through what is NumPy, what is Matplotlib, what is TensorFlow. Please, it is a request. Okay, and go through your activation functions also. Okay, so if you have any difficulty, now you can ask me. All right, let me again show the screen. Yes, Anil sir, please ask the question.
Sir, when can we get those notes and videos, sir?
Sure, sir. Notes and everything, sir. You will get, sir.
Yes, sir.
Okay, fine. Yes, any more thing you want to say? Yes, everyone. If you want to say anything, please let me know. Are you? Are you? Happy with the classes? That's something which I want to ask from my side.